How many times have you installed a modular product asking yourself, what's inside? How does it work? ABB has decided to satisfy your curiosity by disassembling for you the most curious and mysterious devices. Let's start with Type 1 Surge Protection Devices, SPDs. ABB Class 1 Spark Gap Surge Protection Devices are switching type SPDs, according to EN 61643-11 standard. The diagram represents the tripping characteristic of these devices. As seen from the figure, at the occurrence of a certain level of overvoltage, the switching value, the voltage across the module collapses suddenly to just a few volts, the value corresponding to the arc voltage. More the switching process is rapid, more the maximum voltage level across the SPD is reduced, less the downstream electrical equipment is solicited. SPDs protect electrical systems and equipment from impulse voltages and transients caused by lightning strikes and electrical operations. Let's have a look at an example of operation. Without an SPD, the overvoltage reaches the electrical equipment. When the overvoltage exceeds the withstand voltage of the electrical equipment, the internal insulation is not protecting, and the surge current destroys the equipment. Without an SPD, an overvoltage of 6 kV hits the power supply of the server. The electrical isolation among circuits is irreparably compromised. A discharge to ground is generated. After the overvoltage, the server is out of service and a risk of fire is present. The installation of an SPD between all live conductors and the earth limits the overvoltage by proposing a safer path and diverting it directly to the ground. With an SPD, a transient overvoltage of 6 kV spreads through electrical cables. The surge protection device ignites and diverts the surge current to the ground. The residual voltage is limited at 1.5 kV at the terminals of the SPD. The server is on the safe side and protected from the overvoltage. Let's now see how an SPD works. The Class 1 surge protection devices from ABB incorporate a sophisticated electronic control system that facilitates the electric arc, ensuring an optimized level of protection from the SPD. An arc extinction chamber, not present in conventional spark gaps, also interrupts subsequent short-circuit LCC up to 50 kA. In case of overvoltage, the discharge reaches the terminals of the SPD and is detected by the electronic circuit. The active intervention of the electronic circuit switches on the electric arc in advance. The electric arc runs on the electrodes and is directed into the arc extinction chamber. The hot ionized gas flows in the cooling conduits, preventing the risk of fire.